All right, are we recording?
Yes.
Okay, swell. So last time we looked at the law of sines and the law of cosines, and I really like to teach them together so that you have to think, oh, this is an example of one thing or another. You just have to figure out from question to question which law to use. So what if we were given, let's see, let's draw this triangle, and I'm ABC. Oh, sorry. CB. I like to label them this way, and it really doesn't matter if it's to scale. So here we're given that the measure of angle A is 34 degrees, that little a is 11, and that little c is 18. So I know angle, side. And anytime you have that word, you know that you're in the ambiguous case for the law of sines. Bye. Good luck. So let's pull out the instructions that we need to follow. And I'm just going to print this single page out really quickly. Okay, so here it is. This is the handout that I told y'all to print out. This is the overview. There we are. And yes, we're in the ambiguous case because we have two sides and an angle, and that angle is not between the sides. The angle is not between the sides. So the first step is to find the altitude h, where h uses the given angle and the side that is not the same letter. So not the side opposite, but the not opposite. So I'm going to use C and A, and I want to find this height. So H is equal to, if this is theta, H is equal to C times the sine of A. And we know that because the sine of A is opposite over hypotenuse. Well, the opposite is H. The hypotenuse is C. If we multiply both sides by C, we get C times sine A equals H, which is what we want. So let's do that. Let's see, we've got A is 34 degrees. C is 18. And I'm finding my phone. Here it is. Okay. Come on, get out of there. There it is. Okay, sorry about that. I want to make sure that I'm in degrees. So for mine, if I'm in radians, radians actually shows up. So otherwise I'm in degrees. And I want to find the sine of 34 and multiply that by 18. We get 10.1. So H here. And we're going to compare H and the given side. So here we're given side angle A. That means that A is the given angle and little a is the given side. If you use the notation that I used on these. So we get, let's see, A is 11 and H is 10.1. So I can see that A is greater. And also I know that angle A is acute, which just means less than 90 degrees. Well, alrighty, so let's see. Little a is having the role of this G. So let's see. If G is acute, it is acute, and H is less than G, is H less than G? Yes. And is N less than G? Is 18 less than 11? No, it's not. Of course not. So what? So now we do have H is less than G, but G is smaller than N. So G fits in between. Little a fit in between C and H because H is 10.1, A is 11, and C is 18. And that means that we will have two triangles. And I tried to make this diagram clear. So here is our example. We've got A equals 11. So this has to be also A equals 11. Here we have C equals 18. And we have angle A equals 34 degrees. We can have this side A out here, but we can pivot it so that it stays inside the triangle, inside this angle, and we create two triangles. So we've got, let's draw them. We've got one triangle with a, little c. And see, where C is definitely going to be acute. And then we'll have a second triangle. Side A, angle C, angle A, little c, where this angle C is obtuse. So we're going to have two angle C's, two whole triangles. One triangle will use the acute value of C. The other triangle will use the obtuse value of C. And now let's see how we get to those. But it's really important for us to know, and that's why I put all of this detail, because if you know where you're going, then it's not as hard. So we know that we've got this situation. And we said it was law of sines because it's the ambiguous case of the law of sines. So how can we use the law of sines here? And we always start with the acute version of this angle C. Since we're looking for an angle, I'm going to put the sines on the top. So I have the sine of C acute divided by little c equal to the sine of A divided by little a. And I know everything except C acute. I'm going to multiply both sides by C. So I know that the sine of C acute is C times sine A divided by little a. And that's 18 times the sine of 34 divided by 11. Okie doke. So we've got 34 sine times 18 divided by 11 equals. So we know that the sine of angle C is 0.915, blah, blah, blah. Let's take the inverse sine, and we get that the acute value of angle C is 66.2 degrees. Just because it's good to see how we get from one to the other, let's look at what has to be true if we can pivot this side A. We're gonna get a different color. We're gonna take side A and pivot it there. So let's see, got these two sides are the same. That means that the two angles at the base are the same. Is that a nice off-leaf triangle?
Yeah.
Okay, good. So that means that This angle is C acute. What do I know about C obtuse and C acute if this is the configuration? Here's C obtuse, here's C acute. What do I know about them?
They equal 180.
Perfect. C obtuse plus C acute equal 180 degrees. We already found C acute, so let's go ahead and find C obtuse. Next, 180 minus 66.2, 113.8. And I know that this is probably right because this is definitely an angle greater than 90 degrees. C acute is an angle less than 90 degrees. So this is looking good. Now the hard part is over. We're just going to solve one triangle using C acute, whole triangle. And then we're going to do another triangle using C obtuse. And let's make some tables. So some things in here that are going to be the same, but we know that A is 34 degrees. That little a is 11. That little c is 18. Everything else is going to be reliant on which C we have. So here we're going to have C obtuse, and here we're going to have C acute. So it really isn't that hard to find the two triangles, but it's important to know that you need to find the two triangles. Okay, well, let's start with the acute. We know two angles. What can we do with that? Can we use this information to the third angle?
Yes.
Yeah, sure. We know that B is going to be 180 minus 34 plus 66.2. So that's 34 plus 66.2 plus 180. We get 79.8 for angle B. So the measure of angle B, and I'm going to put acute because it's going with the acute triangle. It's 79.8. Now we've got all the angles, two sides. We can use the law of sines to find the third side. And I'm going to use angle A to find the little b, because we're given those values. So we've got the sine of b divided by little b. Oh, we're looking for b. My bad. Little b over sine b equals a over sine a. I mean, this is not wrong, but why is writing little b on top easier?
Is to keep your constant on the top?
Yeah, because it's easier to multiply than to divide. So we're keeping the thing we're looking for on the top. Here we're looking for little b. When we were looking for an angle, we put it in the numerator. So it's whatever you're looking for, it helps to have that thing in the numerator so that you can multiply both sides by the denominator. And then you've got your, it's easy to find then the value. So we've got little b is equal to little a times the sine of angle B divided by the sine of angle A. There you are. So we've got little, let's do the sines first. We've got 79.8 sine divided by 34 sine, and then times little a, which is 11. And we get that side B is 13.4. Now, I'm going to put a little capital A for acute next to that, because this value for B and the value for angle B all relied on using the acute value for angle C. So we have B acute equals 13.4. It's a good idea when you're solving triangles to make sure that if you go smallest to largest, 19.4. If you go small to largest, that the sides and the angles should match up. So the smallest side is 11. Is 34 the smallest angle? Yes. And which angle is largest? Well, like B is side the longest. And since it is, we're happy. So we're probably doing right. Now we're going to use the same capital A, little a, and little c, but then we're going to use the obtuse value for MC.
Miss Snell, your audio is chopping off.
Okay, I'm going to pause the okay, great. So we're using angle A, little a, and little c. The obtuse value for C, that'll change things because it's the measure of angle B. We subtracted A plus C from 80. We're going to do this thing, the measure of angle B, and we're just going to call it B obtuse so that we know where it belongs. It'll be 180 minus the sum of 34 and 113.8. So let's see. 34 plus 113.8 equals, negate it, add 180. We get 32.2. And now we're going to use the law of sines to find the side opposite this new angle B. But the setup is the same. So we've got little b obtuse is equal to A times the sine of B obtuse divided by the sine of A. It isn't that B is obtuse, but that this value for little b, big B, go in the obtuse table. Okay. So let's see. We said that B was 32.2. Sine divided by 34 sine times 11. So side B is going to be 10.5. And let's make sure that this makes sense. So we've got little b is 10.5. Which angle is the smallest?
B.
Yeah, good. So we've got B is smallest. Is side B the shortest?
Yes.
Yes, good. And I can see that it's very close to the length of little a, and angle A is very close to angle B, but it's larger. And then the longest side is opposite the largest angle. So that looks good. And let's check our answers. I don't know why I like to check answers. So we have 19.4 and 79.8, 66.2 and 18. And for the obtuse, and I guess I could delineate these better, but I just use the little a and little o inside the table. I need to label them like this. That'd be better. But we have 34, 36 point, wait, 113.8. Oh, let's see. This is interesting. So perhaps I subtracted incorrectly. Let's see. Or the notes are wrong. Either is possible. I write all of it. So let's see. We've got 34 plus C obtuse is 113.8 equals, negate it, add 180. 32.2. Good. So we were correct, and I will correct the notes. And for B obtuse, we got 10.5. Okay, groovy. I just want to do one more thing. before we leave this, one of my favorite parts, the law of signs and the law of cosines. So say you're just sort of a public spirited person and you notice that there's a nice green area in your neighborhood and then it has sidewalks on 3 sides and you're curious what the interior angles are. So you measure the length of the 3 sides and you want to figure out, how do I find the angles? So I'm going to label it so that I know numbers, what letters go with which things. So I've got little a is 132, 122.5. Little b is 120, and little c is 89. If we know 3 sides, what does this say that we need to use?
Law of cosines.
Good. And we have to start with the longest side. That's pretty important. Okay, so let's see. The longest side is side A, so I need to start with A by itself. So A squared, it's the sum of squares of the other two minus the other two multiplied by 2 times the cosine of the angle that matches. All right, well, this is easy. We have 120. Oh, let's solve for cosine A first. So subtracting, we get A squared minus B squared minus C squared. And then we're going to divide by the coefficient of cosine A. And let's make life easier for us and find 2 times BC. So 2 times 120 times 89. I got 21,360. And now we can find the numerator. So A was 122.5. B was 120. And C was 89. And remember that, oh heck, pardon my language. So we have 122.5 squared minus 120 squared minus 89 squared equals. This is negative, but remember, we found the product 2BC. We didn't use that negative. So we kind of were thinking of that negative moving out front, but now we have also a negative in the numerator. So what does that mean about the sign of this answer? S-I-G-N. What is a negative times a negative?
Positive.
Positive.
Good. Thank you. Oh, thanks, Krista. So let's see, we're going to divide by, I'm going to change sign, divide by 21,360. Heck. I'm glad I wrote it down. So I've got 7314.75 divided by 21,360. So we know that the cosine of angle, oh, let me move this. We know that the cosine of angle A is this number. So I'm going to do inverse cosine. So 69, I'm going to round that up to 70. So the measure of angle A is 70 degrees. Okay, well, now we can use the law of sines or the law of cosines to find the next angle. What do y'all want to use?
Sorry, could you say that one more time?
Yeah, sure. Now that we've got one angle and all three sides, we can use the law of sines to find the next angle, or we can use the law of cosines to find the next angle. It's just whatever y'all want to do.
Let's try law of cosines.
Okay, groovy. So let's go in reverse order. We did the longest side. Let's do the middle side. So we know b squared, and I'll have cosine angle B. I have to put the other two squares and minus these two times 2. That's pretty easy to remember. Since I'm looking for angle B, I'm going to do some algebra in advance, just like we did here. So we'll have b squared minus a squared minus c squared, all divided by negative 2ac. And that will be equal to the cosine of b. Let's see. A is 122.5. C is 89. What do we get? Yeah, 122.5 times 89 times 2. So the denominator here is 21,805. This negative, I'm moving out front. And now I have b squared. B is 120. So 120 squared minus a squared minus 122.5 squared minus c squared, 89 squared equals, and we get another negative. So that's good. We've got two negatives. The end result will be positive. So this is going to be 8,527.25 and divide by 21,805. We get that the cosine of angle B is 0.3901, blah, blah, blah. Inverse cosine. We get that B is approximately, I'm going to call it 67 degrees. How do y'all want to find angle C? Well, let's do it two ways. So how do y'all want to do one of the ways? Do law of sines. So we've got angle C, so I'm going to put the sines in the numerators. And A was the first angle we found, so I included that one. Multiply both sides by little c, and we get that the sine of angle C is little c times the sine of A divided by side A. Angle A was 70 degrees. Times little c is 89 divided by, and little a is 122.5. So the sine of angle C is 0.6827. And we get that angle C is approximately, I'm going to call it 43 degrees. So C, measure of angle C, is approximately 43 degrees. And to check, let's just add them. So we know that the measure of angle A plus the measure of angle B plus the measure of angle C should equal 180 degrees. And we said that the measure of angle A was 70 degrees, that the measure of angle, can y'all still hear me?
Yes, ma'am.
Yep.
Okay, swell, thank you. The measure of angle B should be degrees, and the measure of angle C is 43 degrees. Already that it's going to work, but let's go ahead and just add. We have 70, 67 plus 180. Yay! So then now you can go to the city planners and say, I have an idea to make this easy. And you can do some trig on them there. Today I'm going to set the stage so that y'all can do these 5 try thises. And the last one is an application, but you can see the triangle and you know how to use the table to see which one you do. And the answers, but just the answers are here. All right, I would like to stop the recording and start again. Y'all mind 5 minutes?
Yeah. It'll take 5 minutes.
Thank you.